1, Chapter 3, Section 7, Solving Absolute Value Equations and Inequalities. This is the first thing I'll be looking for in your notes, and this is a vocabulary word for expression. Now, an expression is a word or phrase that communicates an idea. A mathematical expression is a mathematical phrase. For example, both these are mathematical expressions. A mathematical expression can be numeric, means made up of all numbers, or algebraic, meaning it has a letter involved. As a review, we want to write an expression for each word phrase. Take a moment, pause this video, at least mentally work through these 4 questions, and turn the video back on and see if you've got the right idea. M increased by 8, so it's M increased by 8. That means 8 more than M is another way of saying that. Y divided by 9. Y divided by 9, or the quotient of y and 9 is another way of saying that. U more than 7. Notice the U comes at the end. 7 increased by U, or U more than 7. Along the bottom here, we have 3 expressions. One of them is not algebraic. Which one is not algebraic? Well, the one with all numbers. Algebraic expressions have letters in them. The second thing I'll be looking for your notes is this statement. To solve absolute value equations, you can use the fact that the expression inside the absolute value symbols can either be positive or negative. So if you have the absolute value of x is equal to 7, you know that x can either be equal to a positive 7 or x could be equal to a negative 7. When solving these equations, you take your absolute value symbol and you break it up into 2, in this case, equations, but it can also be 2 inequalities, and solve each one individually. To solve the absolute value of b equals 3, you need to realize that b can equal 2 things. Do you know what they are? That's true. 3 and negative 3. So to solve the absolute value of x minus 5 equals 6, you need to realize that this x minus 5 part can equal 6, but it can also equal negative 6. So there's our 2 equations. When h plus 7 equals 2h, that means that the h plus 7 can equal a positive 2h, and it can equal a negative 2h. See a little negative symbol here, make sure you see that. Take a moment and read this and put this top section in your notes. That's number 3 in your notes I'll look for. And let me talk about what it actually means. When dealing with a compound inequality, which would be any absolute value that's an inequality, you are going to look at when the absolute value of 5x is greater than 3, you have 2 equations. You have 5x is greater than 3, and you also have 5x is less than negative 3. Notice, not only did I make there a negative sign here, but I also changed the inequality sign. So that would mean which one of these along this line would be true. Now it's not going to become a less than equal to sign. It's not going to change it from a greater than and less than sign to a less than equal than sign. So these 2 are out. Now ask yourself, 5x is greater than 3. Which one of these has 5x greater than 3? Now double check yourself, because is that the same as saying 5x is less than negative 3? Yes, 5x is less than negative 3. Let's look at the next one. Here we have 3x is less than 5. So 3x is going to be less than 5, and 3x is going to be greater than negative 5. Once again, we did have the inequality change when I allowed it to be negative 5, or when it became negative 5. The less than sign did not become less than equal than sign, so those two are gone. And looking at this, which one has 3x less than 5? Right here we see 3x less than 5. So let's verify it by looking at the next one. 3x is greater than negative 5. Yes, 3x is greater than negative 5. Let's take a look at example 1. You don't need to put this in your notes, just follow along. As you can see, we have the absolute value of x minus 2 equals 5. So we need to test the fact that x minus 2 is positive and could possibly be negative. So looking at the positive case first. When x minus 2 is positive, x minus 2 would equal a positive 5. We would add 2 to both sides and get x equals 7. Looking at when x minus 2 is negative, that would mean x minus 2 equals a negative 5. Add 2 to both sides, so x equals a negative 3. Now this creates a union. So when x could equal 7, and, that's what this little symbol means, remember from last video, and x equals negative 5. That's an and. Put this in your notes as example 4. This is a bit more complex than what you've seen up to this point, so it needs to be added to your notes. Looking at this problem, you see that 2x minus 7 is inside the absolute values, but you have this minus 5 that's outside this. Well, if you remember, the absolute value symbols are often grouping symbols as well. So that is grouped. So we're going to get rid of this negative 5 first before we go on. To do that, we're going to add 5 to both sides. So we have the absolute value of 2x minus 7 equals 9. Now we're going to look at the case where 2x minus 7 is positive. That means it equals a 9. And where 2x minus 7 is negative, which means it equals a negative 9. Continue to solve. So 2x equals 16, divided by 2, divided by 2. So x equals 8. On the right-hand side, we add 7 to both sides. So 2x equals a negative 2. Divide both sides by 2. And x equals a negative 1. So our solution is where x equals 8 and where x equals negative 1. This does not yet need to be added to your notes, so please take a look at this as I do it. We're going to graph the values that satisfy the below inequalities. So the absolute value of x is less than 8. Well, that means that x is going to be less than 8 and x is going to be greater than negative 8. So in graphing that, we're going to take 8 and negative 8. And notice that x is larger than negative 8, but it's smaller than 8. So it's in between them. That's a case where the absolute value of x is greater than 8. That means x is greater than 8, and x is less than negative 8. So graphing that line, you see that x is greater than 8, and x is less than 8. That is an OR, which is a union. So an AND statement is an intersection, and an OR statement is a union. This is a repeat of the previous slide with the information I want you to have neatly typed out. Take a moment to read it and then go on. Let's make this the fifth thing in your notes. We're going to solve the absolute value of x minus 4 is less than 3. So when x minus 4 is positive, it'll be less than a positive 3. When it's negative, it will be greater than a negative 3. Add 4 to both sides. So x is less than 7. Add 4 to both sides. So x is greater than 1. Now, since the absolute value is less than 3, we know the inequalities are connected by an AND, or a intersection. So we have x is greater than 1 and x is less than 7. So this is our final solution. This is number 6 in your notes. Here we solve the equation, the absolute value of 2x plus 1 minus 3 is greater than or equal to 6. So we need to first isolate the absolute value. Now remember, that's a grouping symbol. So to do that, we're going to add 3 to both sides. And when we add 3 to both sides, we get the absolute value of 2x plus 1 is greater than 9. So we have the case when it's positive, it'll be greater than 9. And when it's negative, it's going to be less than a negative 9. Go ahead and solve it. Forgot my equal than sign there. Again, solve the negative version. So this is our case. X is going to be greater than or equal to 4, but it's going to be less than or equal to negative 4. Since the absolute value is a greater than, the inequalities are connected by or. So you're going to have a union. So this would be how your solution's written. 7 in your notes, you do not have to write the story problem out, but make sure you're writing the workout and understanding where all the problem coming from. A company makes boxes of crackers that should weigh 213 grams. Now, any box that varies from the weight by more than 5 is sent back. So what's the range of allowable weights? Well, allowable weights is going to be less than or equal to 5 grams. Well, what's less than or equal to 5 grams? Well, the actual box weight minus the 213. Now, this could come up to be a negative number, which is why we're using absolute value signs, because it could be more by up to 5 grams or less by more than 5 grams. But we're looking at this difference. So to solve this problem, we're going to use x minus 213 is less than or equal to 5. And then the negative version, which is x minus 213 is greater than or equal to negative 5. Solve it by adding 213 to both sides. So x is less than or equal to 218. And we have solving this side by adding 213 to both sides. So x is greater than or equal to 208. So this is an and. So we know that 208 is less than or equal to x is less than or equal to 218 as our final answer. Take a moment and work through the lesson check. You do not need to write this out, but make sure you understand how to do this type of problems. If there's any questions, make sure you bring them to class tomorrow. And then obviously make sure you know how to know what an absolute value is, know what an equation is, know what an inequality is, and tell me how you feel about this so far. Bring any questions you have to class tomorrow.